So yes, this is the title of my talk, and you might have also noticed that it's the only talk of the four that doesn't include ideo or idiolectal, because I'm mainly working here. Well, I've worked also on authorship attribution, but this talk is going to focus on profiling. And to visualize what I'm going to talk about, that's me, as you can see, and let's assume that I write in lots of different platforms in lots of different ways. In my wildest dreams, I'm also a columnist on The Guardian, and I'm also, to complicate things, writing in different languages. So my native language is Italian. I communicate regularly in English. I try to communicate in Dutch. How can you tell if I write in all these different ways and platforms and languages that is still me? So this is a very, as we've seen already and we know, is a very complex task. I'm gonna complicate it by adding language variation, but I'm gonna make it simpler, because instead of just saying whether it's me, let's try to find out what at least we can say that it's a female writing. Now, in order to be able to make this valuable and meaningful, the first thing that we have to see is whether we can actually tell whether a text is written by a female or a male to start with, even within genre, even within the same data set. So thanks to Tim for introducing the PAN concept before. So with a group of students, we participated in the 2017 challenge on author profiling that had tweets from various languages and variations of languages. Like they had variants like from where these languages are spoken. So English had Australia, Canada, New Zealand, etc. And Spanish had also like various places and so on. But here I'm going to concentrate on just the gender. And the task was just to, given some tweets and a certain amount of evidence for author, can you tell whether the tweet was written by a female or a male? So with my group of students, we set up a baseline, and the baseline is n-gram based in very much the same way that was just described in the previous talk in terms of conceptualizing the information. So we use just character n-grams, so sequences of 3 to 5 characters, and word n-grams, so 1 to 2 words, and we weighted them using TF-IDF, and then we just passed this information to a linear support vector machine with standard parameters, and this was our baseline. And we got pretty good results. And we thought, okay, well, we can surely do better than this. So the results were very high. So what we tried to do was to add more data, like more tweets or even like other kinds of data. We tried to experiment with more features. We used part of speech information. We tried to use dependency relations. We tried to use a lot of other features. And also the SVM by now is a very robust and strong classifier, but with all the neural networks that are going on these days, we thought we can do better than that. But eventually nothing of this worked, just nothing. And our best model ended up exactly the same as our baseline model. If you try to find a difference, there is no difference. And it was not only the best model for us, because this gave us, this is us celebrating, this gave us the best score of the whole PAN competition. There were like over 20 teams. And we were very surprised, and we were also very surprised by the high scores. If you see, they are all in the 80s for gender. And we called our system n-gram just to give it the, just to give the idea of the intrinsic value of it, which was just basically relying on n-gram. So this is a strongly lexicalized model that does extremely well, like over 80% on average on Arabic, English, Portuguese, and Spanish. So we thought, well, this is really good. However, this really, really strong lexicalized model, and very simple, as said, relies on just surface information, just sequences of characters and tokens. And we wondered whether really this was doing so well. So we wrote a paper about this where we actually left it at, is this really true? Are we really doing so well? So what we did, we also took data from the PAN 2016 challenge that actually had implemented a cross-genre setting. It was still all on social media, but it still asked systems to be trained on tweets and then be tested on blogs or reviews. So we did a whole setup where we wanted to see whether our strongly lexicalized model that was working on Twitter was also successful on profiling, on blogs, and on reviews. Now, in this slide, you show the various settings that we used. What actually the core message is here is that We used Twitter as training data, and then we tested on blogs and on reviews and on other types of social media. And when you see the arrow going to itself, is that because to have an idea of how well we would do within data set, also for the other data set, we ran cross-validation experiments on those. Now, if we just go directly to see the results, well, we see that we don't see any 80s anymore. Results are all lower. So if you look at the first top of the table, you see results across, so cross-genre. So the training is Twitter, we tested on blogs, we tested on other kinds of blogs, we tested on reviews, and results are very bad, very bad. So if you actually look at the in-genre results on these other data sets, results are also very bad. So we thought, okay, well, this is also to do, of course, there's some cross-genre effect, but there must be also some sort of bad data effect. So that also has to be considered and has to be taken into account. So what we wonder was the Twitter data particularly special to start with than on its own it was achieving such much better results? So all this, as said, is always done with this n-gram-based SVM that seems to work very well. So again, it's very, very lexicalized. Yeah, remember that. Now, what we observed, just to sum up, is that in dataset, this model can achieve, depending on the data clearly, 80%, and cross dataset, we couldn't get like much. Let's say that. It's very disappointing. Now, letting aside all the issues about the quality of the data set that actually have to be, of course, also taken into account, but it's pretty obvious that we needed to check, to investigate this further. So what we thought was that there was too much in this strongly lexicalized model. What we thought was that there was too much of in-data set information that was being used. And this was because the lexical information is very strong in this sense. So the way that people write on Twitter and in the specific range of time that was considered in the data set, because training and test data were coming from the same distribution. It wasn't, of course, the same data, and it wasn't the same authors, but it was coming from the same also time distribution. So people were talking about similar things probably. So we thought this was constraining. This was a big factor playing into the high score. So if you reduce the help of lexical information by basically showing test data that comes from a different distribution, we have lower scores. But is it really a bad thing to have these lower scores? Well, in a way, I don't think so. And we wrote another research paper on this, where we did this kind of analysis. And then we suggested that this really had to be further investigated by having some cross-genre evaluation settings that were stable with good data, properly controlled, and so on. And this brought to the organization of 2 shared tasks, one for Italian and one for Dutch, where we really aimed at testing this cross-genre gender prediction. One was organized within the Evalita 2018 campaign. So it's a shared task like, more or less like PAN, but it also involves other tasks, a bit like SAMeval, for those of you who know that. And we have 5 different types of writing that you see up there on the right. And we also organized something similar for Dutch, where we had 3 different types of writing. Now, there were several participants, and again, there were different models being trained. Eventually, there was a little bit of neural network success, but also SVMs were successful. And I'm going to show you just very briefly the results in genre and cross genre. So what you see is the max in was the max observed result, the best result that we observed in genre. And the max cross is the best result out of all the participating systems that we observed cross genre. And then you see the average for both. Now, it's pretty clear to see how results are not exciting. And again, these are not exciting even in genre. So there's something, again, with data, but I'm not going to go into the detail of this, but you can ask me later. I'll be happy to discuss this because I think I know what's going on here. So we can talk about it, at least up to a certain point. I know what's going on. So, but what we see is that in and cross are clearly in cross, there's a drop. Yeah? And the same actually happens for Dutch. So the in results are not as high as the 80s that we've seen before, but in any case, the average cross are all lower. Okay. So what we wanted to further investigate then is A, try to better understand what's going on in this data sets, because we've seen 80s, but we've also seen 60s or 65s. So what is it exactly? But also, we wanted to sort of be forced to abstract away from the lexicon to see what's left. So if you don't have the lexicon anymore to rely on, what actually can you rely on to make your guesses? Yeah, so this is for a machine, but I also would like to ask you, if you look at this, you don't need to answer to me because it's going to be hard in this context. If I had you in person, I would ask you to raise your hands, but just think about it. This is Dutch. I'm assuming that several of you don't speak Dutch, but if you just see this, can you make a decision as to whether this is written by a male or a female? What do you rely on? And then assume that a machine is in the same situation, like it has been trained on a lot of data, and then this data is not useful anymore when it goes to test because it's seen a lot of lexical information that is not replicated in test, is not there. It doesn't find any clues. So can you tell if this is written by a female or a male? Well, you can think in your mind, and this is a female, and this is the same. Is this a male or a female? You can think, you can look at it and go like, what are my clues? Can I see something that actually indicates one direction or the other? What am I basing my decision on? This is a male. We're going to go back to that. But what we wanted to do was to put a machine in this situation and see what it could do, whether there was still some signal left. So we invented, used this technique, which is, it's very crude. So linguists, and mind you, I'm trained as a linguist, linguists often just get a bit upset about this because it is very crude, but I think it still yields extremely interesting results. So we use bleach, and what we do with this, we run some experiments where we cancel out as much lexical information as possible from a tweet. So we bleach the tweet and we are left with a sort of skeleton of it. So we take some potential features for bleaching. So you get a tweet, and what you get as output is this kind of list that you see below. And you go like, what is it? Well, I'll tell you what it is. So the first representation where we remove lexical information, but we preserve some structure, is the length in terms of characters. So A becomes 1 and B becomes 3. Yeah, so it still preserves some information, but there's just no characters explicit anymore. Then we also use some binned frequency. So we take very frequent word will be in like bin number 4, and low frequent words will be in bin, or lower frequent word will be in bin number 2, and so on. So 0 would be the lowest. Then we have a vowel consonant representation, and you can see how this works, of course, only for certain languages and wouldn't work for all. And we transform basically a word into a sequence of consonant, vowel, and so on. And we do the same with the lower and uppercase or anything else. And then we also use punctuation, and we do it in a way where really everything is just, we call it aggressive, where everything is wiped out. So you see a little bit of punctuation at the question mark, at the exclamation mark, and then you see the emoji represented just by J. But we also do it in a more conservative way where we keep the signal of the punctuation and also of the emoji explicitly. Now this is more sparse, but of course is a little bit more indicative. And now what do we do with the spinal representation? We train models in the same way that we did before. And this allows us to circumvent the problem of lexical or strongly evident lexical information. So it reduces it, but still maintains some signal in that sense. And we do it to a bigger extent, we thought, of cross-genre, because we do it cross-language. So for example, we train on bleached Dutch and we test on bleached Italian. Yeah, so I hope that the setting is clear. And this way, if you had to do it lexicalized and we do it as a comparison, it will be very hard because the string that you see in Dutch, you're not going to find in test for Italian. So we take an existing corpus of tweets, which are for Spanish, French, Dutch, Portuguese, and we add English from a different data set. We don't do any processing, basically, and we train two models. One is lexical, which is a linear SVM, the same model that I've been telling you before, very simple. So that relies on lexical information. And the other one is a bleached model, which uses 5 grams. Okay, so basically the sequence of the 5 bleached characters. Yeah, so we use a concatenated representation of all the different translations for each tweet, and we train a bleached model on it. I hope the setting is clear. So the first model really is like the one that I described before, that takes lexical information, and the bleached model takes these different representations. Yeah, and what we do in language, we do cross-fold validation, 10-fold cross-validation, and when we do it cross-language, we do either one language at a time and we do average, or we train on all of the other concatenated languages. Results of the lexical model. If you look at the accuracy on the right, you see the 80s coming back, but not for English. And English comes from a different data set. Now, this is all in language, but that tells you again something about the quality of the data set. So that's something that we always have to bear in mind. So clearly the quality of the English data set is a little lower. Now, what I want to show you then is what happens if we run the lexical model cross-language. So that means that it's a poor model that has been trained, saying, on English, and then it sees Portuguese tweets. I mean, that's not going to go too well, right? Because it only relies on sequences of characters and words. So what has it learned if it's seen English and now it has to make predictions on Portuguese? That's not helping, right? And as you see, all the scores are pretty bad, apart from if you look at the Portuguese situation and the Spanish situation when they're trained on a closely related language, like if you train on Spanish and test on Portuguese, you do a little bit better than if you train on Spanish and test on English. Yeah, so you can compare the 61.2, which is pretty good, and well, comparatively to the 50, just baseline results. And here, up here on the right, I reported the previous lexical results just as a comparison. So what we see with a baseline of 50% is that if we do it in language, the lexical model is much better than the abstract model, so the bleached model, but the bleached model is above baseline. And that indicates that there is some signal there. There must be, otherwise it wouldn't be above baseline. Now, if we do it cross-language, we see the reverse. So the lexical model performs worse than the bleached model, because the bleached model is able to capture some signal at the general profiling level. We're not talking about idiolect here, we're really talking about profiling, but it's able to capture some signal even across languages. And to conclude this experiment and also the talk, what we also wanted to try is actually how humans were performing in this. So we had an in-language performance, like seeing, a Dutch person having to evaluate Dutch tweets. Can a person say whether a tweet is written by a female or a male? And then the cross-language situation, where a Dutch person with zero knowledge of Portuguese was supposed to say whether a Portuguese tweet was written by a female or a male, and the same for French to Dutch. Now, we used 20 tweets as evidence for one person, and we used 3 annotators, and we tried overall to balance the annotators per gender, like these people. And what did they see? They saw what I showed you before. So say that there were French people who had to say something about Dutch without absolutely having no knowledge of Dutch. We checked with these people that they had not been exposed, they didn't know Dutch, and hopefully they also didn't know German, and sure, they know English. They might infer something, but still. And then they had to tell whether they were posted by a female or a male. Yeah, so that was the task. Now, how do they do? If you look at it in language, the lexical model does actually better than people. And people and the abstract model, the bleached model, perform more or less the same. Now, if we look at the cross-language situation, then you see that actually the lexical model does bad, as these are the same scores that I showed you before that were just in a table. But the human and the bleached model perform, well, more or less at the same level. It doesn't mean that they're doing the same thing, but there's still something that you can capture if you don't rely on the lexicon. Yeah, so this is actually quite interesting to see. And this is definitely better than the machine. Now, we also tried bleaching cross-genre, because that's actually how it all started. And it just doesn't work. We don't see the signal that we saw cross-language. Why? To me, that's still an open question. But it seems to me that genre really is a stronger constraint problem, so it constrains much stronger production than if the same person on the same genre talks in different languages. So to answer the question, do author that I started with, so do author traits survive variation? Well, I still don't know. I think for the evidence that I have so far, I think my answer should be no. But I really would like to come up with the optimal experimental setup for an NLP experiment to answer this question. So together with a student, Maaike, who's here with us today, we're trying to come up with a proper experimental NLP setup to answer this question. And we've put up a document. You can access it via this QR code to share ideas over this. I hope if you're interested in, if you are an NLP person, but maybe also not, can we try and come up with like what we should be testing with what data and how computationally to answer this question. So that's it from me. I'll just leave you here with a list of papers that I've mentioned and that this talk was based on. And thanks so much for listening to me.